The last type of plot we're going to look at in this module is a stem and leaf plot. These are relatively new and they give you some advantages over just a bar chart or a table. Please make note that the password for the next assessment is leaf. A stem and leaf plot uses digits to the left of the rightmost digit to form what we call the stem. Each rightmost digit forms the part we're going to call the leaf. For example, a data value of 147 would have 14 as the stem and 7 as the leaf. The stem and leaf plot will look like a sideways bar graph, but it uses the actual data so you can read the numbers off if you need them later. You'll notice when you did a bar graph, the actual data points are not visible in the graph itself. You get some of the visual effects of a bar graph without losing the actual data values when you use a stem and leaf plot. In this example, an individual is considered to be unemployed if they do not have a job but are actively seeking employment. The following data represent the unemployment rate in each of the 50 states plus the District of Columbia in June 2008. We let the stem represent the integer portion of the number and the leaf will represent the decimal portion. For example, the stem of Alabama will be 4 and the leaf will be 7 because the unemployment rate is 4.7. Write the stems in a vertical column in increasing order. If we go back to the data and scan, we notice that the smallest data value is 2.8 and the largest data value is 8.5. So our stems will go from 2 to 8. Then we're going to draw a vertical line just to the right of the stem so we can separate the stem and leaf sections. And then we're going to write each leaf corresponding to the stems to the right of the vertical line. And I can't put this on the slide, but you would look at that table of data and each data point you would just go down through there and write the decimal portion of the number. So we came to 2.8, so that is a stem of 2 and a leaf of 8. And if you check this table against the data, you'll see that all the data points are in there. Because there's so much data, I just wrote them down as I came to them, and then I'm going to need to sort them. So within each stem, I need to rearrange the leaves in ascending order. You can see where I put the 3 stem with its leaves in order, and then the 4, and the 5, and the 6, and then of course the 7 and 8 only had one data point each. So once you get the data into the plot, then you need to have a title for your plot. And the title here is Percentage of Persons Unemployed, June 2008. And then you need to provide a legend to indicate what the values represent. A stem of 2 with a leaf of 8 represents the number 2.8%. It's a good idea to count the leaves to make sure you didn't leave out any data. If you had 30 data points, then you should have 30 leaves. If you need more examples of stem and leaf plots, try the following link. And this is another example below of some running data that has been put into a stem and leaf plot. If the data are too bunched in a traditional stem and leaf plot, the stems can be split. That's equivalent to adding more classes to a frequency distribution. So here's a split stem and leaf plot. The first 3 stem represents the numbers 3.0 through 3.4, and the second one represents 3.5 to 3.9. and so forth with the 4. We go 4.0 to 4.4 and 4.5 to 4.9 and so on. Once a frequency distribution or histogram of continuous data is created, the raw data is lost unless it's reported with the frequency distribution. However, the raw data can be retrieved from the stem and leaf plot. So that's an advantage of a stem and leaf diagram over a histogram. You can actually retain your data. Now, our last objective in this module is to identify the shape of a distribution. Once we have created a bar graph, we need some terminology to describe the shape of the data. Most everyone has heard of the bell curve. That's what perfectly distributed data would look like. And that's where the term curve my grades comes from. What you're really asking is for the grade data distribution to be made in a perfect bell shape. But actually when you do that, the majority of the grades are in the C range and only a few in the A and F and then the B and D range. So most people wouldn't really want grades curved because some people who made A's would get pulled back into the B or maybe the B's back into the C range. So this is a histogram that is bell-shaped. The blue curve back there has been drawn around the data to demonstrate that bell curve. However, most data is not perfectly bell-shaped. So here's some examples of different shapes of distributions. We have uniform symmetric. We have a bell shape that's symmetric. We have a skewed right, and we have a skewed left. Symmetric means that you could fold the graph in half and it would roughly match up. So while both A and B have different shapes, they're symmetric because I could fold them in half and they would roughly match up. That would not be true of the graphs below. Skewed means that the data is lopsided, so if I fold it in half, it's not going to match up. If it's skewed right, it means that the tail or the thin part is on the right. So this data is skewed right, and we would call this the tail because that's the thin part. And this data is skewed left because the skinnier part, there's a longer skinny part here that is on the left side. This becomes important later because a lot of statistical procedures can only be applied to data that is roughly bell-shaped. A lot of bad statistics comes from applying statistical procedures designed for normal distributed data to data that is not normally distributed. Here's some more examples of data that's skewed right. You notice the tail is on the right side, the skinny part is on the right side. And we'll talk about this later, but if data is perfectly distributed, the mean will be in the middle. If the data is skewed right, then the mean gets drug further to the right. And most of you know, even though we haven't covered it yet, that mean is an average. And here's some pictures of data that's skewed left. And again, the data, the skinny part of the data, the tail, is on the left. And notice that the mean, rather than being at the peak, is drug further left when the data is skewed to the left. So here's your mean way over here, but the peak of the data is over here. Identify the shape of the following histogram which represents the time between eruptions of Old Faithful. Since very little data is on the left side of the graph, this distribution is skewed left. So the tail is over here on the left side. What's the shape of this distribution? This distribution is skewed right because the tail is on the right. You are now ready to take the Module 2 Part 1 Assessment of Learning. When you click on the link, it will ask for a password which was given to you earlier in this presentation.